let's start. Okay, list of dice.
And the original notebook.
Yes. This is the notebook that you sent me, I think. Oh,
Yes, and
original notebook.
lab.
Yes. So it should be this. Okay. Let me take a look at this. Okay, so XE is a random variable associated with a number. Okay. What do you mean by the element list of the dice? Does it mean like let me try to see what you meant. Does it mean like, list of the dice is from 1 to 6, right?
No, it's not this. It is a list containing numbers representing the number of faces of the dice.
Sorry, number.
For example, if there are 4 dice, the first one got 6 faces, the second one 7, the third one 8. The function will take the list of numbers 4, 7, and 8, and then the maximum.
So for example, if I have 4 dice and the first one I get 1, the second one I get 3, the third one I get 4, the fourth one I get like 5. So it will be my K1, right?
No, it's not this K1. K1 is the number of faces of the EF dice.
Of the E. Oh, okay.
Go back to the exercise.
Okay. Yes.
Yeah, suppose that 6-sided die is rolled n times. Let xe be the value of the top ace of the EF roll, and let x the max value of xe for e in range 1 to n. For example,
here. Let me see. Okay, can you say that again, please? I didn't catch it.
yeah, you can go into the function. You see in the example f equals 2, 5, 7. 2 is the number of faces of the first dice. 5 is the number of faces of the second dice, and 7 for the third one.
Oh, okay. So, okay, hang on. Let me read.
This is my K. This is my Ki.
Okay, let me have a look at this. Give me a minute. So in the problem, we assume that each of the dice have the potential number of faces denoted Note F1 and S2 function latches that determine the probability. Use the higher latches face the vector F for positive. Hang on, I'm lost. Let me reread it from here. Okay, if n equal 3 and 3 rows are 4, 1 and 4, then x. What? If n is 3, okay. If n is 3, that means like if I roll out and my face is 3, or is it like there's 3 dice?
No, n is the number of times you roll the dice.
Oh, okay. Oh, okay, I got
The
it.
number of the dice is the length of the list.
Okay, I got it. So, okay, if n is 3 and the row is 3 row and 4, 1 and 4. Okay, so there's 3 dice and the 3 row 4, 1, 4. So if they roll the 3 dice at the same time, right? Then x1, okay, x2 is 1, okay. I got it to find distribution of x. Observe that x, so the x, what is x smaller than x? What that's supposed to mean? X is, I don't, first, why is this is smaller than this? How do you know, how do we know that?
X is the maximum value of the xi. To find the distribution of probability of a random variable, we take the probability that this value is less than or equal to vector x. Is less equal than an occurrence x.
Okay. X be the value of top row E for X. What does this character mean?
Which one?
That one, this one. Like there's a little
I don't know this one.
yeah, like there's a little square on top of it, you know, so I'm not sure like what it's supposed to mean.
Yes.
Okay. X, let's say it equal.
It is the definition. It's the definition. Delta equal to. It is a definition.
Oh, definition. Okay.
Yeah.
Okay. So max E X E
X equals by definition to the maximum value of xe. E range from in range 1 to n.
For example, if n, okay, I got this. So observe the first part that x smaller than x. If okay, maybe can you demo the experience out? Maybe I'll understand it better. So
yes, you know why for x less than equal
yeah, maybe.
x.
Oh, I think I have an idea. So could you maybe share screen and drawing me help me draw out the experience so that maybe I can understand the formula better. I see this formula and I'm lost. I don't know where to start.
Okay.
I'll be on mute and I'll let.
But I don't have. But I don't have the notebook.
Oh,
I don't have a notebook, so
you can.
later.
Oh, we can just share. We can just draw out the experience on here. Like how you relate it in real life. Whoa, like if you roll 3 dice, and what is the parameter and what you're supposed to get, and how is the end of the result. This formula doesn't make sense to me at all.
Okay.
I'm just look at this problem. I'm lost. I don't understand what is one smaller than e smaller than n is. I'm really lost in this. So I'll stop share now and I'll be on mute. So please just continue. And if I don't have question, I don't have any, I don't understand something, then I'll stop you.
Okay.
Oh, yes, I can see the screen now.
Okay. Okay. In their case, in their example, they give us the case where the number of the time the dice is rolled equals to the number of dice. So they gave us 3 dice and you roll it 3 times. But not
Oh, Kamek, I think the voice is having some issue again.
You already see my screen.
Oh, no, it's still starting, I think.
Okay.
Yes.
You see
Oh,
what?
shoots. Yes. Let me, sorry, let me set authorize you. Okay, it should be all right. Okay, it should be all right. It's the same one. I just
Okay. Okay, look. Thanks. Okay. So far, we mostly considered standard six-face dice. The following problems explore dice with different number of faces. But in the example, they are given explanation with 6 face. Right. Okay. This is the function they are asking to write. Input m is a list of integer and m max is an integer. Output the variable type float. Here we want to get the probability of getting larger space as 2 for 2 dices. That could be 3 combination out of total 36 combination. So it makes 2 divided by 6 power 2 minus 1 divided by 6 power 2. Tom, you there? You are there?
Yes, I can hear you.
Okay. So why I try to explain here. Okay. This is here you don't understand. Am I right?
Yes, I have no idea about the formula.
Okay. So they take a dice and they roll it n time, each dice, and they see the top, the number on the top face, and they record it in the variable. For the first dice, the x1, the second x2, the third one x3, and then x is the maximum value of the 3 faces, the 3 numbers which appear. To find the distribution, we should compute the probability of x that's equal than p small x. And this is true, means that for every value of xe is also less than or equal than little x. You understand, Tilda?
I don't understand what is, like one is smaller than e, smaller than n. So I'm not sure about that part.
Here.
Yes.
Okay. You agree with that? This is the max value of the xe. Tom?
Sorry, I cannot see clear. Can you zoom it in a little bit? So x is equal to max.
Yeah.
So let me see. Okay, I can see it now. So x is equal to max value of a xe. So it is in the list of phase, right?
The list of phase appearing
Yes.
after rolling each dice.
Yes. Okay, I understand that.
As it is the maximum value, if it is less than a certain value, it means that every xe is also less than this value. Agree?
So, for example, if I roll the dice and my dice is 4, 3, 1, then the max value is 4, right? So x is equal to the max value.
Yeah, if 4 is less than x than another value, it means that 4, 3, and 1 are also less than this value.
Okay, I got it.
Okay, great. So to compute this probability, let's write a wrote here. To compute this probability is less or equal than x max. It means that x is less or equal than x max for every e in 187.
But I thought like in the below, we just say that x is equal x max.
You see?
But I thought in the below, we just say that x is equal x max.
Yes. Small x
Like
equals
you
x
see
max.
in the one that you just wrote down there, I see that x is equal x max.
Well, in my notebook.
Yeah, below, like the one that you just wrote. Yes, it's equal.
This one?
Oh, it's equal max of x, so it's not equal x max. So is
No.
max of x one is it the same with x max?
No, it's not the same thing. Here, max is a function. In the other, in x max, it is a scalar, a number.
Okay, what?
This is a number. This is a function, maximum function.
I'm a little bit lost. What is a scalar? I heard you repeat it several times, but I'm not sure what it means.
A scalar, it is a real number. It could be an integer or a decimal value.
Could you show me an example of a scalar and how is it different than list array?
Not a vector of numbers. A component of the vector is a scalar.
Oh, okay, so it's just a vector of number.
No. It is a component of a vector of number.
vector is that it would have two values, right?
You said?
Vector is having more than two values, right?
Yes.
Oh, I mean like vector have at least two dimensions. That's what I meant.
Yes, it could have only one dimension too.
I forgot.
Vectors,
But I forgot.
column vectors. So a vector could also have one dimension.
Sorry, vector can be one dimension?
Yes.
Oh, okay. How about matrix? Can matrix be one dimension or is always be more than one dimension?
A matrix, a row matrix, and a column matrix are one dimensions.
Okay, so if we draw vector or column vector, then it's a one dimension.
Yeah.
Okay, I got it.
Right. So here, this is the probability that x is less equal than x max for e in range 1.n. It means that probability of x1 less equal than x max and probability of x2 is less equal than x max. The probability of xn is less equal than x max n times. When you have an intersection of probability, and if the events are independent, if I roll the dice one time, if I roll one dice, it's not dependent of rolling the second dice. There is no link between them. So in this case, the probability of the intersection, it is the product of the individual probability. This is what means the symbol product is equal than probability of x less equal than x max times probability of x2 less equal than x max, still probability of xn less equal than x max. Now, how to compute this probability? You understand still here? Is it good?
Hang on, give me a minute. I'm still reading it. I'm still lost a little bit on the, okay, if probability of x is smaller than x max is, so x max is where we get the largest probability, the largest face value, right? Then
Yes.
px1. So what is, so there's three value of x here is x max and x1, and I'm a little bit confused the difference between those three. So let me go back to my notebook so I can write it down. Here, I'll show you what I meant. So where is it? Okay. Okay, so here is what I'm confused about. Where is it? Okay. So, you know, let's create a cell. Okay, so I don't understand what is the difference between, so x, y, how do you write a little number like this? This, okay, so how do you get the, so right, so I don't understand the x, y, how do you get the,
All right.
okay, but anyway, so I don't understand what it means between the, the difference between xy and the x max. So I know that x max is the largest value of x, right? And x is the number of
Big X, this is the maximum value. The
x is
maximum, no, wait. What do you want? Little x or big X?
this one. I don't. Let me see. So in here it said x. The big X is the maximum value between the x1 and xe, right?
The maximum value of x1, x1, x2, x3, till xn.
Okay, x is maximum value. X1 and maximum value of x1, right?
x2, x3, till xn.
Okay. Okay. So and
No,
just
no. The continuation point is between x3 and xn, not after xn. Xn is the last element.
oh, okay. Okay. Okay, I got it. And so xe is the e value.
No, xe is also a random variable. Even x it is a random variable.
Oh, okay.
Not consider it as the maximum value. This is a random variable.
Okay.
X is a random variable representing the maximum value of this one, of these random variables too.
X max is largest value of xe.
Please come back to x. And before, just at the beginning, this is a random variable.
Yeah.
No, at the beginning of maximum value.
Yeah.
At the beginning of your definition.
Yes.
X colon random variable.
Here, let me give you the control.
Okay. Yeah.
Okay, so X is a random variable. Okay. That's okay. Got X, XE random increase at the phrase at the top after the row.
This one is a little x, but when we are using random variable, we use capital letters for random variable and lower letters for values that they could take. So here, as it is a random variable, it should be in capital letter, and also here.
Random variable. The phrase.
Okay, that is it.
Okay, I understand X and XE. Let's see, random. Okay, value function. Okay.
This is good now.
Yes, I think I got it. So, oh, I have
Correct.
a question. I have one more question. So,
Yeah.
so this is the big X. So, what is the small X? Like this one.
It's the same thing than X max in our case. Just that I started using X max because the function that asks you to write is using X max.
Oh, okay. So,
But the example uses X.
oh, okay. So X is the same. Right, so it's just a function.
You say?
Pardon?
What did you say?
Oh, so X is the same with X max.
Yes.
Ah, okay. Okay, I got it. Okay, this makes things much clearer. I understand now.
Right. So I share my screen or what?
Yes, yes, sure. Please share your screen. I'll stop sharing now.
Okay. So we are here. You understand this part? You understand?
Yes. Let me reread it again. So if X is smaller than our function X max, which we get the largest phase, right? Let me double check on my notebook to see it. So, okay, probability of the largest number phase. Okay. So if X, oh, where I am. Okay, probability of X is smaller than our function X max, then pair X, Y. Okay. What is this little number, little icon? I don't understand this.
This one.
Yes.
It is a symbol for representing the product of elements. I got a call. I'll be back.
Okay, okay. Yes, I think I got it. So I don't understand the little icon.
This one?
Yeah.
Yeah, I say that it is P, P Greek, and it means the product.
I'm still not sure. Share screen again. So could you help me write down that icon? I'm very very bad. I'm terrible in this math icon. So yeah. So could you help me?
What?
Here I don't understand this. Oh, mine doesn't have that icon.
Which icon?
The icon that look like the N. Let me please share your screen again.
The symbol of the product.
Oh, that is the symbol of the product.
Yeah.
So it's the sum, right?
If you want to write it, you should write /product.
Oh, where is it?
Between $signs, $/product.
Oh, here, let me share screen with you again.
Okay.
Okay. So how do you, here, let me let you control my screen.
Okay. Very good.
Yes. Oh, oh, that is the product. Oh, I didn't know. Okay. Yes. Oh, how do you get it to be like in a new line?
In your line, you have to add the break tag at the end of the preceding line.
Oh, okay. How do you do that? Can you show me? Oh, okay. Oh, but in the other one, you didn't add anything. So how does it go down?
Yes, it is a break tag. It is a tag without, we don't close it.
Oh, okay. So, but in here, like there isn't any break line, but there is
Okay,
line.
okay, it's because this is markdown. Markdown, if you get a space between two paragraphs, it goes directly to the line. So another position is to let a space before to start another paragraph.
Okay. Yes, I understand now. Okay. Okay.
I
Oh, let
share
me.
my screen.
Yes, let me stop share.
Okay. Yeah, yeah. You understand till here? So this probability that x is less equal than x max, x2 less than equal than x max, still probability that x e is less equal than x max n times. So it makes the product of each probability. Now, before to compute the product of these probabilities, you should know how to compute each of them. So you take probability that xe less equal than x max. You count the number of phases, the number of cases where the number of the phase is less equal than the number of x max, and you divide by the number of the phase that the dice get. In our case, the number of phase is not the same every time. In the example, it was 6. They suppose that it is 6-sided dice. But in the function that they gave you, it could vary. For example, it could take first 2 faces, but that is strange. Then 5, then 7. Both if I don't understand. They say that in this problem, we assume that each of the n there has a potentially different number of faces, denoted fi, and ask you to write a function largest face that determines the probability p of x that the highest top face observed is x. The largest face takes a vector f of positive integers, interpreting as the number of faces of each of the dice and the value x, and return p of x. Yes, so the number of x differs. So I take ki as the number of faces, I put it at the denominator, and at the numerator, how we are sure that the number of cases where the number of the face is less equal than x max is x max. For example, suppose that, do you follow me?
Yes, I hear you. I'm still trying to follow. Yes.
Okay. Suppose that you take a dice, it gets 6 faces.
Mm-hmm.
In how many cases the number, we take a face with the number, for example, 4. This is a six-sided dice. In how many cases the number of the face is less or equal than 4? There is the face where we got the number 1, the face where there is the number 2, the face where there is the number 3, and the face where there is the number 4. It makes 4 cases. This is the same thing. Every time, whatever the x max we are going to take, the number of cases where the face of the dice is less equal than a certain value equals again x max.
Oh, okay. So first step, we need to calculate x max, right?
No, we don't need to calculate x max. It is a parameter of the function. It is
But then how?
already provided by the user.
But then if we don't know the value of x max, then how do we get the number?
You don't need to get the function. It will be given to the function as an argument.
Okay. Okay, let's try.
You don't need to know it before. So now we come back to the probability that x is less or equal to x max. The product of this one n times, so it makes this probability at power n, raised to power n.
Hang on. So I understand the number of phase where number is less than x max. Okay, number of phase of dice. So is it the product of Oh, I have a question actually. So
Yeah.
let me try to draw on here.
Yeah, there is a mistake here. Wait a minute, there is a mistake.
Okay.
Let me correct it. Equals, it's not directly power n. Okay, that is it. You know why it is a mistake? It is because the value depends on ki. If it was not depending on ki, it would be a constant value. So we could take it at power n.
Okay.
You get me?
No, not yet, but I have a question. So it is symbol and this symbol is the same. Can you see the symbol that I just draw?
No, it's not the same. No way. This one is the product, and this one is the sum.
Oh, I thought
So
sum is the same.
you say?
I thought the product and the sum is the same for the whole time.
No way, no way.
Oh, oh God, what did I miss out at school?
2 times 2 is not 2 times 3 not equal to 3.
Oh, I see. Oh, okay. I make a misunderstanding of the language. So this one is sum, right? So 2 plus 2. And this one is the right?
You get it. Yeah, you get it. But the example you take doesn't help you to make the difference.
Okay. Yes, I understand now. Yes, I understand now.
So we could continue, or you need more
Yes, yes.
explanation?
Yeah, I'm good now. I understand now. We can continue.
Okay, great. So you see, let me try put it here. So, this product is equal to x max divided by k1 times x max divided by k2 times x max divided by k3 n times till x max divided by kn. So this is why I put back the product. If this one was a constant value, this constant value will be raised to power n, as in the case of the
Oh, I have a
example.
question. So I don't understand how they write like this. Like, what is the little n here mean, and what is this one mean?
We are trying to make a product of elements, and there is an index which varies. You have to provide to the product symbols the bounds of the interval in which you could find the index. I don't know if you understand.
No.
This means that
I don't
our
understand. Can you
index,
give me example? Like if I write something like this, and if there's a number, then how do I calculate it? I have the same question with the sum like this, you know, like n and what is it? N minus one. I think I studied, but I forgot. So I have the same, like when I see this, I don't know how to calculate.
okay,
Can you help me revise it?
I'm on it.
Oh, okay, thanks.
Welcome. Have control on my screen.
Yes.
Okay. Okay. So this product is equal to the probability that x1 less equal than x max times the probability that x2 less equal than x max times the probability that x3 less equal than x max.
Oh, okay.
Is cat is 5 and so on is n less equal than x max. So you just it's this index we change. So in which from which value it start and to which value it ends. This is what we wrote here.
Oh, okay.
The lower bound 1, the upper bound n.
I have a question.
Yeah, you got it?
This. So,
Yeah.
so when you say E equal 1, is it the first start of the element, right? So we start at the first element in the list.
the first value that the element take, that the index takes, that this index takes. It takes firstly 1, then it takes 2, 3 at the end, and
Oh, so if equal to, then what does it mean?
if x equals 1, for example, it means that it's the first dice we are rolling.
No,
each
sorry,
one
I meant
is-
like if it's equal to, because sometimes when I see the formula like this, I see it's equal to, so I don't know like what 1, 2, 3 in here it means. For example, so for example, like this, I don't understand like what is 1, 2, 3.
Yeah, in this case, I think that it is the index. The index is called n, not I, as in our case. If the index is called n, they give you the values that it could take directly, 2, 3, and so
Okay,
on.
but if it take 2, that means like it start at the number 2 or it skip 2.
No, it's the right to. I have to see to give an opinion. It is only equals to, it means that it is only one possible value. It doesn't have sense. But if they give you at least two values, 2, 3, it means that it can take only two values, 2 and 3.
Oh, okay, I see. Okay, okay, we can continue.
Correct. So this probability is x max divided by k1, x max divided by k2, and so on. One make the probability is x max divided by k from 1 to n. So this part, is yeah, the same thing here. There is a mistake. It is x max minus 1. So as we did for x max minus 1, we just have to replace x max by x max minus 1. Now we'll go back to our probability we look for at the beginning. So probability, the difference between these two probabilities. So I will replace my bad. Okay. This is in here. This time it is x max minus 1. Got it. Is it good?
Yes.
Great. Next step. So now I think you could solve the exercise. If you now make comparison what they gave you in their example, in their example they say that p of x less equal than x, it is x divided by 6 power n, because it is divided by 6 times x divided by 6 n times. You roll the dice m times. No, it's not the roll the dice n times, because they are n dice.
Okay, could you help me send the notebook that I'll start in my computer?
I send it now or later.
Oh, now please, so I can rely on the formula to write a code.
Okay.
Okay, sent.
Okay, I saw it. Let me download it and. Okay, so let me share screen, then we can start writing function. Can you see my screen?
Yes, I can.
So, let's see. Output. So what is it the probability of they have the lattice phase? No?
You say?
Oh, in here they said print lattice phase to 5A6, 8. So it mean like this is the lattice. So that means like in 8 row, these are the lists, right?
You don't understand correctly. In this example, they are trying to compute the probability that S is the largest here, the largest phase in these three dice.
So in 3 numbers, right?
Yes, three dice, three numbers, yes, three dice.
But then what is the 2, 5, 8?
2 is the number of faces of the first dice, 5 the number of faces of the second dice, and 8 the number of faces of the third dice.
So hang on, let me see the logic here. I'm still a little bit lost. Let me draw out. So we have 3 dice, right? So each one have 6 phase. So this is 6 phase. So if we roll it at once, then we get 2, 5, 8. Then they are trying to see the probability of 8 is the largest. The probability of 8 is the largest amongst the list, right?
Yes.
So isn't that, since we only have the 3 number, so isn't it like the chance of 8 is the largest is 1/3?
Why do you say 1/3?
Because because the list has 3 number, so 8 is one of the 3 numbers. So the probability of is okay, I see. The probability of it appear on the list is 1/3, but the probability of it is the largest is different. Okay, I see now. Okay. So let me try to do it in like layman terms. So okay. So the probability of the first dice being the largest is one.
It's not what they are asking you.
Yeah, I'm just trying to like to understand the formula in like layman term. Like for example, if I like without the formula, how you calculate it manually, then when I see the formula, it would be easier for me to understand.
Okay.
So let me try to.
but you are missing some steps of the experiment.
Okay, can you tell me more?
There are 2 steps. The first step,
Oh, let me
roll
write.
each dice.
Yeah, let me write down so it will help me a lot. Okay, okay. So the first step, right? Oop. Okay, roll dice. Okay. What? So the first step I roll dice, and the second step we have a list of number.
No, you regard the list of numbers since the beginning.
Oh, okay. So we roll dice to get the number of.
If you want, regard the list of dice since the beginning.
Okay. So
Yeah.
now the step is like I get the list of outcomes, right?
First, have a list of dice. Second, we roll each dice in the list of dice.
Oh, sorry, what did you say?
Roll each dice in the list.
Roll each die?
We roll each dice in the list of the list. Look at in the chart.
Okay.
Yeah, sent it.
Oh, okay. Roll each dice in the list. Sorry. Okay.
Now we get a list of outcomes. What is the outcome?
Oh, what the outcome is? Let me see. So the outcome is this, right?
No. Look at the instruction. Look at the what is the outcome?
Hang on, give me a second. Let me take a look. Okay, 3 row 4 1 4.
The outcome it is the number appearing at the top face.
Oh, it is? I'm a little bit lost.
I think they said it somewhere. X will be the value at the top face. This is the outcome. The value at the top face of the dice. You didn't read it?
No, is it?
Suppose that a 6-sided die is rolled n times. Let xe be the value at the top face of the EF roll.
Here.
So the outcome, got a list of outcome. The first outcome is the value at the top face of the first dice. The second, the value at the top of the face of the second dice, and so on.
Suppose 6 side dice row and xe is the value of the top face of the row. Okay. Okay, so xe is equal x max.
No.
Okay, random represent the face appearing at the top. What do you mean like face appearing at the top? What at the top means?
The value which appears at the top face, the value that you can read while you look at the dice from the top.
So, so for example, if I roll a dice and it my value is like for example my value is 258, then what does it mean like at the top mean?
Your value you can be 258. You roll a dice. There is, for example, 2 faces on the dice. Either it is 1 or 2 which will appear. If it's 1, you can see first. This is the value at the top. There is only one value at the top.
So okay, if I have 3 dice, if I roll, first one is 5, second is 2, third one is 8. So what does it mean by at the top? Like, is it 8? Is it the first one is 5? I don't understand that part.
I don't understand your question. What you should keep is that there are a certain number of dice. For example, 3 dice as in the example. You roll it, you roll the first one. You see the number at the top face. You record it. You roll the second dice.
Okay.
You see the value at the top. You record it. And you roll the third one.
Okay. So basically,
so you got the list of outcomes.
Okay. So basically, it's just the value when I roll a dice. So whatever number I roll, I write down. Oh, okay. Okay. Oh, okay. Okay, I got it. Okay. Okay, so I got it. 258. Okay, so where were we? Okay. Okay, so get a list of outcome. Okay, I understand this part. So once we get a list of outcome, what should we do next?
Please give it more precision about what is the element of the list of outcome.
So like, like for example, if our number is 2, 5, the first time we roll, we got a 3, the second we got 5, then the third time we got 6, and that is our list of outcome, right?
Okay, something like that.
Yes.
After you get your list, you make a second experiment. You count, you compute the max value.
Do we need to roll the second one time?
No, you already reach each of them at the second step.
Oh, okay.
And now we try to see what is the maximum value.
In my example, the maximum value would be 6, right?
Yes, in the list of outcome.
Okay, yeah. Okay. And if my max value is 6, then what else do I do?
Now they are asking you to compute. I'm not giving you the steps to solve the problem, because when you were talking before, you were trying to understand what is the experiment. I'm giving you the steps to understand the experiment that you have done. You are agree? Yeah.
Yeah.
So then after,
I'm trying to get the purpose of the experiment. Like once I get the max value, then I don't understand, like, because if I already get the max value, then the experience should end, right? Because we are getting the max value of where is it? Let me see. Yes, because like we are looking to see the max value. So if we find it already, then I don't understand. That's what I was trying to say. Like if we have the list already, then there is no need for us to do anything.
okay, you get the max value. Now they're trying to check if this maximum value is equals to the largest number of faces.
Okay, is equal to the largest faces. So basically, we are trying to see, like, in this list, we're trying to find the value is 6, and we go back and compare it, the 6 to the maximum value of each dice, right? For example, if my dice have So if this is the list of possible value that my dice can have, and if this max value is equal to this list, then then my function is done, right?
I don't understand what you say.
Okay, so the possible number on my dice, the list of possible number that can appear in my dice is this 1, 2, 3, 4, 5, 6, right? Because 6 is the maximum.
No, you have to forget what you know about dice in this exercise. This in the case if the dice got 6 faces. Well, they said you at the beginning that they are assuming that the dice could not have 6 faces. It will have 2 faces, 3 faces, 4. Don't remove it. Let it.
Okay. Okay.
It could have 4 faces, 5, 8, 10. So don't assume that it got 6 faces. And they got the first step, the list of dice they gave you. The first element of the list is the number of faces that the first dice got. Do you understand it?
Okay, hang on, let me write this down. Okay, so each one of these have these 3 value. So
No. Uh, uh, what do you have at the beginning? You have a list of dice. You agree?
yes.
In the list, what is the first element of the list? What does it
Okay.
mean?
This, right?
No, this is not the list. This is an outcome. We are not there. We are not yet there. We are
Okay,
still at the
so
beginning.
this is my list of the value. This is the have a list of
No,
the.
it's not also. It's not also. This is the list of possible values of the number of each face could be. If
Okay,
the
so
6 face
this is
dice.
the list of possible. Okay, so this is the list of possible value of the dice. Okay.
Remove dice 1, dice 2, dice 3, list of possible. Give me remote control, please.
Okay. Can you remote control my?
Not yet.
Oh, that's.
Okay, I can now. So. I'm trying, but I'm not yet reaching to.
Let me.
Okay,
Okay.
it's good.
Okay.
It's good. Is it good now?
Yes.
Is it good?
Yes.
Okay.
Yes.
Oh, this is our list, 3 set 9 4. Then after rolling, if we roll the first dice, equal the possible values are 1, 2, or 3. So at the first time we got 3. This one, the value will be 1, 2, 3, 4, 5, 6, 7. We got 5. 1, 2, 3, 4 is 9. We got 6. The fourth one, we could got 2.
Hang on, I don't understand that part. So what do you mean, like 1, 2, 3, 4, 5, 6, 7, and I got 6? In here, for example, if the list of dice, so there's 4 dice, and the first time I roll, I get a face of 3, then I record it to be 3, right? So basically, this list and this list should be the same, right?
No.
Can you tell me more? Oh, okay. I have a question. So why? Oh, so you are select the maximum number in each of the outcome.
Of course.
Oh, okay. So the dice is not only limited to 6, you can be any number, but then the list of dice is the one that you get the maximum number.
Yeah.
Oh, okay. Okay, so in each of the list, you roll again. Okay.
You got it to the step 5.
Yes. Okay. So I have a list of dice and okay, 3. So okay. So I'll compare the step 4 with with the list of that step 1, right?
Yeah, we got the list of dice.
Okay. So I compare the step. So after I got the list of dice, then I roll, then I get the list 3, 5, 6, 2. Okay. So the max value is 6, equal to the largest number of face. Largest number of face is this one, right?
No. The largest number of face is the maximum value of the list of dice.
So basically, I need to check if 6 is equal to 9, right?
Right.
Ah,
Wait. Yes, you will have to check, but it's not in our function. They don't let you check if it is equal to 9.
Yes, I know, but then the largest one in the list, like any of the 4 dice, they will have like the largest number of those, and I need to check equal to those, right? What I meant is that like the 6 at the number 3, so it's belong to the third dice. I don't need to compare it to the third dice, but I could compare it to any of the other number in other dice, right?
Please repeat again.
Oh, okay. So 6, the number 6 here belong to the third dice, right? 1, 2, 3. So it belong to the third dice. So I don't need to compare it to the third dice, compare it to the outcome in the third dice only, but I can compare it to the whole thing, right? So let me switch it up a little bit. So if this number, for example, is 10, right? So this is 10, and this is 6. So the 6 is the answer of the third dice. So you see, like here is the third dice. Its maximum is 9, right? But then, so I don't need to compare it to the third dice only, but I could compare it to the fourth dice.
This time I'm lost. We should remove this part.
Pardon?
I should remove this part.
Oh, okay.
And I should precise what I am doing. The steps of the experiments. The first step, we got the list of dice. We roll each dice in the list. We get the list of outcome. We see what is the maximum value. When we got the maximum value, we assign it to our random variable. The x. And now this random variable, we are trying to compute the probability that this maximum value is equal to a given value. Yeah. Compute the probability that x equals a given value. Yeah, this is there. You should create a function.
So the given value it is, right?
No, the given value is not there. Not necessarily there. The given value is one of the possible values that is either 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh, okay. So it depends on the dice.
You said?
So it depends on the dice. For example, if here the largest value is 6, so it compare it to the third dice only. Right, so it cannot compare to this one because this one is belong to the second dice, and the 6 here is belong to the third dice.
Yeah.
Because we have 4 dice here. So is it like we compare x to x dice to this group, or do we compare it to, okay, let me draw it out for you. I have another meeting soon, but let me quickly draw it out. So okay, we have 1, 2, 3, 4, right? We have 4 dice. So so for example, in the Okay, and it's we have the value. So in here, we the maximum value is 6, right? 6 here. Then we compare it to the list of the value here, right? We could compare to the list here or list here or list here. That's what I meant.
Well, practically in the function, I don't know how it will be out, but I just did how to do it with the probability. I don't know how
Oh,
to do it
okay.
yet in the
Okay, okay.
but to understand how to do it, I should have a root to the formula.
Okay, okay, sure. Okay, let's continue it again tomorrow. Could we meet at 7? Because I have another meeting now. So can we meet at 7 tomorrow?
Okay, sounds great for me.
Okay, so good for me too. All right, I'll see you later. Bye bye, Amek. Thank you so much.
Bye. You're
Bye.
welcome.
Yes.
Have a nice Sunday.
Yeah, thanks you too.